7 Instrumentation Engineering A 2021. The input-output characteristics of a temperature sensor is exponential for a thermistor, thermocouple, RTD or a mercury thermometer. We have to choose one among these options. For a detailed lecture on these concepts, please refer the NPTEL course or video, Lecture 7, Thermistor, a lecture series on industrial instrumentation by Professor Alok Barua, Department of Electrical Engineering, IIT Kharagpur. Let's have a look at the basic idea required to answer this question. For temperature measurement, we have so many devices. We have RTD, we have thermistor, we have a thermocouple. Thermocouples are of so many types. There is a J type, there is a L type, there is a N type. We also have radiation pyrometers to measure very high temperatures. RTD is used to measure low temperatures mostly, and pyrometers are used to measure high temperatures. Okay, let's have a look at the question. We need to find out the temperature sensor which gives an exponential output for a temperature input. The input is naturally temperature, and the output of thermistor will be in resistance. In thermocouple, it will be in volt because a EMF will be generated proportional to the difference in temperature of the ends. This is based on Seebeck effect. In RTD, based on the temperature, the resistance value changes. The resistance at a temperature T is equal to R0 into 1 plus alpha delta T, where alpha is the material constant. And mercury thermometer, we all know. The mercury expands based on the temperature, and the level of mercury will give us the temperature that's been measured. So comparing all these, we can easily eliminate both of them. In a thermocouple, if we see, this EMF will be proportional to the difference in the temperature at the ends, which is T2 minus T1. So this is going to be a linear relationship. Let's have a look at thermistor now. In thermistor, we have a constant called beta, which is equal to T2 multiplied by T1 divided by T2 minus T1 into natural logarithm of R2 divided by R1, where R1 is the base resistance and R2 is the changed resistance. T1 is the temperature at the starting range, T2 is the temperature at the ending range. So based on these, we can find out the constant beta. The input will be temperature and output will be the change in resistance. If we find out R2 is going to be exponentially related to T2 and T1. So which means that this will give an exponential characteristic. So the correct answer is option A, thermistor.